Elementary graph operations and applications, BFS and DFS. Graphs are a fundamental data structure used to represent relationships between entities. They consist of nodals, vertices, and edges connecting these nodes. Graph traversal algorithms like breadth-first search, BFS, and depth-first search, DFS, are used to explore and analyze graphs.
Breadth-first search, BFS. Operations. 1. Starts from a source node and explores all its neighbors before moving to the next level of neighbors. 2. Uses a queue data structure to keep track of nodes to be visited.
Here is an example for breadth-first search. BFS is a graph traversal algorithm that explores nodes level by level using a queue. Starting at a node, it processes all its neighbors before moving deeper. For example, starting at node A, it enqueues processes it and then enqueues its unvisited neighbors, BCD. This process continues until all nodes are visited. BFS is useful for finding the shortest path in unweighted graphs, ensuring nodes are processed in the correct order.
Applications. 1. Finding the shortest path in an unweighted graph. 2. Detecting cycles in a graph. 3. Social network analysis, finding connections between people.
Next is depth-first search, DFS, operations. 1. Starts from a source node and explores as deep as possible along a branch before backtracking. 2. Uses a stack data structure to keep track of nodes to be visited.
Here is an example for depth-first search. Depth-first search, DFS, is a graph traversal algorithm that explores as deeply as possible along each branch before backtracking. Let's walk through the steps of DFS with a sample graph. We start at node A. First, we push A onto the stack, then pop and process it, marking it as visited. We push its adjacent nodes B and E in reverse order, E first. We proceed to E, process it, and push its adjacent node I. We continue visiting nodes, pushing their adjacent unvisited nodes onto the stack in reverse order. For example, after visiting node B, we visit its adjacent nodes, C, F, J, in reverse order, J, F, C. This continues until we backtrack to earlier nodes when no adjacent unvisited nodes remained. Eventually, all nodes are processed in the order EIBJFCGKDHL. Key points. DFS uses a stack to explore nodes. Reverse order for pushing adjacent nodes ensures correct traversal. Nodes are marked as processed once fully visited.
Depth-first search, DFS, applications. 1. Topological sorting, ordering tasks based on dependencies. 2. Finding strongly connected components in a graph. 3. Solving puzzles like mazes and puzzles.
Here is the representation of how both the graphs work.